Hello everyone and welcome back to another video in the Frogger Replica series. So today's plan is going to be attempting to create the cars on the road. So let's take a look real quick at what we actually have right now. So here is what we have. We have a really simple scrolling set of objects, and each one of these objects has their own class instance. So this is a lane, this is a lane, this is a lane, this is a lane, and there's only ever 10 lanes at the same time in memory. And once it goes off the screen, it gets deleted. And once it goes off the screen from up here, one gets added up here, sorry. Yeah. So that's what we have so far. Today, we're going to be trying to add some cars that are going to be moving left and right moving right for now. That'll be the frog's main obstacle in this game. So it's going to be kind of confusing because we have these lanes going downwards, but we're going to also have cars moving up and right. But we'll see left and right, but we'll see how that works towards the middle of this episode. We're also going to have to use very similar methodologies as we did last time, because once a car goes off the side of the screen over here, we're going to want to teleport it back to the front, or we delete it and spawn a new car at the back. So let's go and plan how that might actually look. So we have a lane, right? And we know the lane's width. We have a representation for that internally in the code for the lane's width, because the lane's width is just the same thing as the screen's width, right? So we know this width right here. What we also know is that we will have some cars, okay, that will have their own width. Let's call this c.w, car width. So the car width right here, we are going to want to spawn in some cars, and they're going to be moving it by their own c.speed, car speed. So the car width cars are going to be spawning. Once they get to the end, so once the car is completely off the screen, once the car is completely off the screen, we're going to want to install or spawn a new one at the end, just like we did with the roads. So it's going to be exactly the same. Probably we're going to have to reuse a lot of that code. And we have car.speed, which is going to be the amount we increment by every single frame. And that's going to be, I don't know, we'll set it as 1 for now. And yeah, we'll also have another variable for how many cars we want in every lane at any time, because we don't want to have a completely blocked lane. Although we could, I think we should have a gap between the cars. Let's call it c.gap, right? So that's going to be the distance between two spawning cars. And I think what we could do is say that if there's a car here, there's with a certain probability, like a 70% chance, we spawn a car exactly the gap behind. Actually, the spawning will happen on the leftmost side if it's moving to the right, and the spawning will happen on the right if the cars are moving to the left. So I think what we'll have to do is we're going to have to define a lane as a right lane or a left lane, right? So cars moving right, well, that will be a lane right, a right lane. And if the cars are moving to the left, that'll be a left lane. So let's go and try to implement this stuff into code right now, and we'll come back to this image often. So here we go. This is the road class that we wrote last time. We're probably not going to be touching this too much because now the lanes work all by themselves. So we're going to go to each lane. Now each lane is going to have its own constructor. So inside here, we're going to have, so it's going to be Y, and then we're also going to have something called direction. Now that direction is going to be just 0 or 1 being left or right. So we'll just call it like that. So we'll say this dot direction equals direction. And just as a note to self, we'll say 0 for left, 1 for right. So it's just an integer value. And whatever we spawn the lane, let's just put it as default as 0 just for now, because I don't want to be, let's put it 1 because we want the right lanes first. And we won't touch it for now. We'll keep it just like that. Okay, perfect. All right, so now that we have the car's direction, we also are going to want to start implementing a car class, right? Because we're going to have an entirely new functionality. We're going to encapsulate it into one small file that we're going to reuse a lot. So let's call it car.js. So this is probably one of the last classes that we will have to make. So it's going to be class car. And again, we just call it a constructor as normal. Now, as we do, as always, we're going to have static variables. So it's going to be static car width, which is going to be, as I called it, the length of the car. And we'll put that as, I guess we could put it as like 100. And then we're going to have static car length. Now, these are slightly weird to think of. Car length, you'd think is the left-right distance. But because I call X and Y wide and up-down height, it's going to be the car height like this. The car, it's called car height. Yeah, car height. There we go. Car height. Perfect. So let's make the car height something less. Let's make it like 75. Or actually, we can make it lane.lane width. Lane height, sorry. Lane.lane height times like 0.9. So it's going to be 90% of the lane is going to be covered by the car in the width-wise. And the length-wise is just going to be 100. So we can call this car length. That will make more sense. And that's good. All right, perfect. There we go. So now what we're going to do is, as always, we do this. We import the car script into our main thing so we can use all the functions that we're writing. There it is. Perfect. And now we have the car constructor. I think each car, as we did before with the lane, where each lane has a Y value associated with it, each car should have an X value associated with it because cars are going to be moving from left to right. So we're going to call it Y. It's going to have a Y, and it's going to, we'll call it X as I just said, and then we'll call it this dot X equals X for now. So this is going to be whenever we spawn the car, it's going to be spawned at this X value right here. So there we go. So now each lane, as we said before, is going to have an array of cars. Okay, so let's call it this dot cars. And for now, it's going to be an empty lane, an empty thing. But we need to do exactly like we did before, where we have to have a number called begin cars, which is just going to be how many cars we want at the beginning, right? Number of cars on lane to start with. So now what we'll have to do is figure out exactly how many cars we want on the lane. Now, as we discussed before, we don't want to fill up the lane completely with cars, right? So let's just move down a bit more from here. We don't want, whenever we have the lane like this, say we could fit 4 cars in, right? 1, 2, 3, 4. We don't actually want all 4 cars, right? We want to have a gap for the frog to eventually move in. So I think what we should do is first spawn in 4 cars and randomly delete one. Or we say we have 3 and we randomly pick 3 spots out of the 4 that we want. So I think it's going to be something like that. So I think what we'll do is the number of the begin cars is going to be, first off, how many cars can we fit in the lane? Well, it's going to be the lane's width, which is the screen's width. So it's just going to be the capital width that we decided was the global variable. Before here in main, we have this width right here that defines the width of the entire screen. We're going to take width, we're going to divide it by car dot car length. Now see, that's why I wanted to call it car width, just so it would make a bit more sense. So this is going to be number of cars in lane to start out with maximum, right? So that's the maximum we can actually fit in a lane. Now also the car length, although it is 100, we're going to draw it slightly less. So let's make a new static variable. It's going to be called draw car length, because we don't want to actually draw the car. Actually, it would make sense. It would make sense that we draw the car the exact length. Then we're going to have to add a buffer. So static, as we defined it, car gap, right? That's the distance between the 2 different cars, c.gap, car.gap. So we're going to call the car gap for now, it's going to be 10. So it's in front of every car we want a gap. So the car's length actually increases by that gap. I hope that makes sense. Car.car gap. There we go. So then because we have every car, we have a car, and then we also have this tiny bit here that's going to be the gap between it and the next car. So we want to add both of those distances together. So there we go. So let begin cars is going to be width divided by car length dot car plus car dot car gap. That's going to tell me how many cars we can actually fit. So now what we want to do is basically modify this and delete a few cars from it. So what I think we should do is let's just multiply it by like 0.7 and then floor it. So let begin cars, so begin cars, and then we'll say actual cars. So let ac cars, so the actual number of cars we want is going to be begin cars divided or multiplied by 0.7, and then we're going to just floor the number, which is basically means round it down, force it to be rounded down. So that should give us an approximation for how many cars we want. So let's try creating a new lane, and let's get it to console log all this stuff. So console.log, which basically just means print out to the console. We're going to print out the begin cars that we chose and then the act cars. Now, because we're spawning lanes so often, we're going to see it spam us here on the console, but let's just take a look at what happens. Lane is not defined, car is not defined. Why is that happening? All right, welcome back. Sorry, I found the issue. So the problem was here in car, I was calling lane.lane height here, And what happens is, since lane.lane height, that means we need to import the lane class into car, but then we go to lane, and lane uses the car class in itself. So it's basically like an infinite loop where lane needs car, and for car to start, we need lane to start. So I just decided to just break that and do it like that. Or we could have defined all of these inside lane. That would work as well. We'll just keep it like this for now, because I don't think I'll be changing this lane width much. And if I do, I'll remember to come back here, because I'll see some messed up stuff happening on the screen. So for now, we should look back here, and we should see the two things being printed. Let's remind myself what I actually called them. So 17, here we go. So begin cars is going to be 7.272. It decided that we're going to have 7 cars be able to fit on this lane. And of them, we only want 5. So that means there's going to be 2 gaps between the cars. Now, I think that's good. But I also think we should be able to change this a bit, because it's 5, yeah, sure, but I want some lanes with 4, some lanes with 6, for example, maybe some lanes with 3. So we should go back here, and we can do something real quick where we go random.rand. Actually, we could just go random like that, I believe. And that random number is between 0 and 1. So we want to make sure that it goes between 1 and 1, right? It's not 1 and 1. We want it to go between 0.5 and 1, because we don't really want a lane with no cars at all. So to do that, what we can do is we can do random divided by 2, which basically means we take a number from 0 to 1, we divide it by 2, which means now the numbers are generated between 0 and 0.5, and then we add to it 0.3. So everything here should be working exactly like we wanted. Now let's just delete one of those. There we go. Okay, so we're taking a random number between 0 and 1, dividing it by 2, so it's going to be 0 and 0.5, and then we're adding 0.3, so that becomes 0.3 to 0.8. We can mess with this number. We can make it 0.4 maybe even. Let's just take a look real quick. Let's see what happened. Perfect. So 4, 3, 4, 3, 4, 3, 5. There's a few with 5. And if we change, oh, and there's one with 6 right there. 4, 4, there's one with 6 right there. 4, 6, 6. There we go. Sounds good. Now let's see what happens when a new lane is generated. Let's make sure that this is printed as well. Okay, new lane should have been generated right now. There we go. Perfect. Okay, another one got picked with 4. The next one got picked with 3. Next one got picked with 3. Perfect. So everything is working right now. Everything's working. We'll toy with the 0.4 soon. We could even make it a constant up here. A static, sorry. So we'll make it static. We'll call it car spawn prob offset, right? It doesn't really matter. 0.4. And then we can just go here. And when we're calling it, we call it lane.car spawn prob offset. There we go. And we'll say here 0.5 plus this value is the maximum fill of lanes of a lane. All right, sounds good. Now we have a car. Technically, we have the amount of cars we want, right? So now what we need to do is populate this cars array with an amount of these car classes. So let's get started now with an exact display function, right? So because as normal, we want a display function that displays this car. And this lane, the parent lane, is going to call display on all of its child cars. So what display is going to do is, as always, when we're drawing in P5, we push and we pop. That's always my etiquette, what I do. And we're going to fill it. Let's just call the cars, make them red for now. We can make it like there's a few different colors to choose from to make it more interesting. We're going to fill it with red. And then we're going to stroke with black as normal. So 0, 0, 0. And then we're going to stroke weight. We'll keep it as 1. I have to retype all of these because of the push and the pop. And I want to make sure that everything inside of here is exactly how I want it. And then now we're going to draw a rectangle. The x value of it is this dot x because we're taking its own constructor from the left, right. The y value is going to be its parent lane's y value. So it's going to have to take a y value to be drawn. And there we go. That's the y value. We'll call it parent y. Parent y. And there's the y value right there. Parent y. And now width and height. So width and height, these are going to be, as we said before. So the height of the car is here, car height. So it's going to be car height. And the width, which comes first, is going to be car length. And there we go. So that should be drawing a car in the correct position. So now let's go and call that function, call that function for every single car in the parent lane. So for now, we're just going to say this dot cars dot push a new car, okay? And that car's X value, for now it's not moving, so let's just put it kind of in the middle, just for now. Then we're going to go to in its own display function. After we draw the road, we're going to call, we're going to call its own a for loop, okay? So for, let I equal 0. I is less than this dot cars dot length. You've seen this all before. We're going to iterate through every single one of the cars, and then we're going to say this dot cars, thank you, this dot cars I dot display. So we're going to display, and then what do we have to give it again? We have to give it this dot y. We have to give it the parent y, which is this lane class's y value. And there we go. We should see, oh, I spelled stroke weight wrong. Let's go back and fix that. There we go. And now we should see in every single one of the lanes, we have a car or something that could pass for a car. I mean, it's not centered. It looks kind of ugly, but we'll sort that out. So everything seems to be working exactly like we wanted. Now, here's a benefit of using push and pop like we did before. I want to make sure that this car is drawn centered exactly. So inside this push, we can go and say rect mode, and we can say center, or I think it's capital center. And that basically means that now the x and y that we give it are going to be center coordinates. So the x is going to be the same because we want its x value to be the same. Its y value, though, is not going to be the top left corner of the lane. It's going to be the parent y. It's going to be the top left corner of the lane plus lane height divided by 2, because we want to add half of a lane, because we want to go from top left corner to the middle. We should see that fixes the car. And now the car is perfectly in the middle. So this is what we decided to be the car's height and the width. So let's try to make it seem a bit more realistic by toying with these properties now. So I think the car height should be about 80% of the screen of the lane. There we go. That looks a lot nicer. And let's see if the car length could do with a bit of lengthening. I think we should keep it 100. I think we keep it 100. It'll be good. There we go. All right, so we have all of that working now. So now our goal is to have a car speed. So we'll go again, static, and it's gonna be car speed. Now that car speed is something that we'll set to 1 for now, just like how we had a lane speed up here, or it's in road, lane speed. So we should actually put this car speed in lane, technically, because in road we have the lane speed. So in lane we have the car speed because it controls the cars. So we'll have display, and just like in road, how we have a function called increment, we're going to do that exact same thing for inside lane. We're going to call it display, we're going to call it increment, and this is going to move all the cars in the correct direction, because remember, we do have cars moving in different directions, in the correct direction for the lane. There we go. And now inside increment, we're going to go, again, we're going to loop through every single one of the cars as we did before. But this time, instead of displaying the car, we're just going to say this dot cars I dot x plus equals lane dot car speed, which is what we just called before. So now we should see the cars moving to the right, but increment is not being called. So again, every time, now when is increment called for the road? Increment is called every single time, every single frame, we're calling increment. So I think it would be valid that every time we call the road increment, we should also increment the lanes. So we'll say for this dot, every single one of the lanes plus equals this dot road lane speed, and then this dot lanes I dot increment also. So we call increment on that place as well. And now we should see the cars moving, and that's exactly what we wanted. The cars are very, very slowly moving. It is kind of trippy and confusing to see the cars moving at the same time as the lanes, but everything should be fine working there. Now I think we can do with the cars being a bit faster. So I think we should put the car speed, 5 is probably too much, right? 5 is not bad. We'll keep it at 5 for now. So now what we want is we're going to do the same thing as we did before. Whenever a car, we want to have 2 different functions: add a car at the end, or delete a car, add a car at the beginning, and or delete a car at the end. So inside lane, we're going to do exactly the same as we did in road. We have add lane, delete lane. Inside lane, we're going to have add car, and we're going to also implement delete car. So as normal, inside add car, I think we'd probably reuse all of this code as I said before. So inside add lane, we're just going to add car. So if this.cars.length is less than 1, then this.cars.push new car, and it's going to be put not at 0 because we want it's the top left value. It's going to be 0 minus, or you could just put negative 0 minus car.car length, right? Because we want to put it just off of the screen. So yeah, there we go. So we'll put 0 minus car length. That's the start position. So if there's no cars in the array, we put one right off of the screen. Else, if there is one on the screen, then it's going to be last x. So it's going to be x value of the last car. It's funny that this actually works perfectly. Last x, so it's going to be the x value of the last car, which is going to be this dot car, this dot cars, this dot cars dot length dot x this time. So it's taking the last car's x value, and what we want to do is add one on either the left or the right, depending on the direction of this lane. So this is where it gets a bit more confusing than with the lanes, right? So this dot cars dot push new car, but where do we want to put it? Well, it's going to be last x, that's for sure. But is it plus lane dot lane height, or is it plus car dot car width dot car length, or is it minus? Well, let's take a look at what happens. Let's say we put it at plus for now, and let's call add car a bunch of times. Let's put the speed down just so I can type. There we go. So we have lane. Let's go road.lanes, and let's just pick the first lane. All right, well, I already lost it. I'll do it again. I'll do it next time. Road.lanes, and we're going to take the first car, okay? And, or we'll just call add car, just the function. There we go. Oh, that's pretty interesting, but I don't know what's going on right there. Oh, yes, of course, because the cars are spawning in the middle every time. Yeah, so add car, let's call that. There we go. So a car is being added to the lane correctly. So if the cars are moving to the right, we want to add the car behind it, right? Because we want to add the cars back in the list. So it's going to be add car, this.cars.push, we're going to subtract from it the car length, and we're also going to subtract from it the car gap that we decided of before. And we should see now, whenever I call add car, we add a car exactly the place it should be. There we go. Beautiful. Perfect. Now what we want to do is implement delete car. Oh, no, sorry. That's not done yet. We need to check. So it's minus. We have to put two minuses if this dot direction. All right, so if this dot direction equals 0. So if we're moving to, what did I say? 0 is what? If we're moving to the left. So if we're moving to the left, what we want to do is this exact same thing, but with pluses. There we go. Else, we do this, which is basically, if we're moving to the right, we do this. And I'll just write a note to self. We'll say, based on direction, add car to left or right of the last one. Beautiful. Now let's take a look at delete car. We can just delete the last car of the array, and it'll work exactly perfectly no matter which direction you're moving in, I think, because we're adding the cars correctly, which means the order of them will be the same. So I think we can just call this.cars.shift just like we did here. I think so. Let's take a look at that. So first off, we're going to add the car, and then we're going to really quickly delete the car. Oh no, I can't even. All right, well, let's try that again. First off, let's call delete car. I know the lane is not visible anymore, but let's go. Here we go. So let's add car, and then let's delete car. Beautiful, and it deletes it in the correct location. So that's working. Now let's test if the lanes are left. So let's put all of the lanes being to the left. And also, I forgot really quickly in the increment function for the road, when we're calling increment right here, we need to increment the car speed based on the lane car speed times this dot direction. Now the problem is I assigned left being 0, so I think it would be smart if I went back and changed left to be -1. That would make a lot more sense, because then it would make my life a lot easier. So we'll go back to -1. Every time we check if direction is 0, we can just do that right there, and I think we're good. And now we're multiplying by that. Now we should be able to check. Now all the cars are moving to the left. Let's try add car. Let's try delete car. Beautiful. Everything is working exactly like we wanted. Okay, so I've been thinking about how I'm actually going to spawn the cars into the lane, because as I said before, this is going to be slightly harder than it was with the lanes, because the lanes, we add them no matter what, but with the cars, we're only going to add them so that there's a few gaps in the lane. So I think what we could do is create a new function that calls add car. So that add car function that we called, should be called only once in a while. So for example, if we have 7 spots as we decided before, and we want 5 cars in the lane, that's about a 70% probability of there being a car in any specific spot. So I think what we could do instead is just take a random chance, and if the probability is correct, spawn the car and call add car. Else, fake the add car and just make it a blank, so nothing gets called, but the system should still think there's a car there, just so we can handle the object collection and everything like that. So I think what we'll do is let's try that out right now. So let's go to add car, and let's go to lane, sorry. And here we have add car. Let's create a new function called try add car, which basically is just going to try to add a car, but it doesn't have to, right? So we'll say if this.cars.length, what we're going to do actually really quickly is this number here that we said let actual cars, we should save this as a class variable, just so we can come back to it later. So this.actual cars, we'll actually fix this up correctly in a bit to spawn the cars, but we'll do this for now. So try add cars. So if a random number from 0 to 1 is less than actual cars divided by this dot, I guess it's just going to be the number of cars we can have, which I guess we'll call it the same. So this dot begin cars. So this lane will basically have a specific population, and that's what this thing controls, just so we're not recalling this random number every single time. If I put this down here, then that random would be changed every single time. So I want to call it just once, set it, and store it, and leave it at that. So in each lane will have their own probability. So it's going to be this.act cars divided by this.begin cars. Right? So that's the probability that we said. So if that random number is below that probability, we're going to actually call this.add car. Else we don't add the car, right? So else we just don't do anything at all. So we just leave like that and we just return nothing. There we go. So let's try doing this now. So begin cars is not defined. Where does that happen? Begin cars is not defined. I think right here, this dot begin cars. Yes. So I need to call this dot begin cars right there. Beautiful. There we go. So now let's really quickly, let's just add in this function into the console. Try add car. So here we go. Try add car. There we go. Oh, yes, of course. So I didn't do the mistake that I did last time. When I said try add car, it added it to the end of the array. There's no car there, and so it adds it directly behind the old car. So what instead we actually need to do is, I guess, think about like a way to have the next car we add be separated by a gap. That's what we're trying to do right now. Okay, so I've come up with a solution to the problem. It's slightly bad code, but honestly, at this point, it's not going to be causing too much of a memory leak, because once the lane leaves the screen, all of this is going to be deleted. So any real bad thing that happens that lasts only that long won't be too bad. So we could do this for now. What I'm going to call it is here as a class variable, which is going to call it this.addGap, right? And that's going to start as 0, okay? We're just going to start it with 0, but then every time we add a car, try add car, else if we're not adding a car, we just go this.addGap plus equals car.car length, which is going to be one car length and a car gap length, right? And then what we're going to do is here, when we're calling last x, it's going to be that last car's x plus this.addGap. Beautiful. So now we should see exactly that happening. So we should say try add car. Okay, there we go. Okay, it didn't happen there, but then there we go. So then 2 car spaces were missed and then a new car was spawned. And that's perfect. That's exactly what we wanted. So now what we want to do is start actually getting the cars to spawn at the beginning. And then next episode, we'll deal with the deleting the cars on one side, adding the cars on the other side correctly. So once the cars are spawned, which is right here, we want to spawn this many cars on the lane. It doesn't actually have to be that much, but the proportion of the cars needs to be this much. So the proportion needs to be the ratio between this one and this one. So here, instead of adding just one car, what we're going to do is we're going to this.cars.push. We're not going to this.cars.push. We're not going to do that. We're just going to say for let I equals 0. I is less than this dot act cars divided by this dot begin cars. So we're going to go that many, as I just said. Okay, so instead of this dot act cars divided by this dot begin cars, we're just going to go up to this dot begin cars, which is going to be about 7. And each time we're going to try to add a car. So this dot try add car every single time. So we should see now a random proportion of cars spawning, and that is beautiful. Some lanes are much less sparse than others. This one is more sparse. This one's like this. It's going to look much less weird once we add the different lane directions. But actually, let's do that right now. So it's going to be this dot try add car. Let's make the direction -1. Let's make, so then let's go to road here. When we're spawning the lanes, here in the add lane function, we're going to this dot lanes dot push new lane, and the direction is going to be a random number between 0 and 1 as normal. But then what we're going to do is we're going to multiply it by 2 to get it between 0 and 2, and then we're going to subtract 1 from it to get it between -1 and 1. So you need to actually get really used to this random number generator, because it generates between 0 and 1. You could easily make it generate between any number and any number by a simple function. But I will just keep doing it like this for simple stuff like -1 and 1, or 0.5 and 1, for example. So we have this. So random, we're multiplying by 2, so it's going to be between -1 and 1. And then and then it'll be 0 and 2, and then we're minusing 1, so it's going to be between -1 and 1. And that's perfect. So then now we add a new lane like that. Okay, else we'll add a new lane there, and this exact thing as well. Let's just delete one bracket. There we go. All right, so now we should be generating randomly direction lanes. And there we go. We should see the cars. Beautiful. Everything is working. That is good. See those 3 cars in a row? That's unlikely to happen. I bet you the next car isn't empty. Yep, boom. The next car is empty. So this is the lanes. I don't know what's going on up here, but we will... Oh, no, that was just an empty lane. That was just by luck. So the game now is, I would say, pretty close to us being able to implement a frog into it. But next episode, we're going to get the cars regenerating correctly, because if you look at the memory snapshot, there was 1.4 when I was taking all the previous snapshots for just the lanes. And then once we started adding cars, there was 4.7. That was when there was a bunch of cars, and now it's 6.7. So you can tell there is some memory leakage happening. We can even check here, and we can see if we look for the car. This is called the memory management of the browser. So you can go here, and if we look for car, right here, there's 132 cars in memory. And it's not taking up too much, it's taking up 2,000. But if we look here, there's 132 of them. Each of them are unavoidable, because on the screen right now, there's maybe like 15, 20 total. Okay, so now back to the actual generation of things. I think that there's so many lanes that have just no cars at all, and that is slightly concerning. I think that's because the probability was too low. So good thing we made a variable up here that we'll be able to change it by. So we'll make it between, instead of 0.4, we'll make it 0.45. So it's going to go pretty fast, and then there we go. So now we have this one. Okay, yeah, so there we go. Everything should be fine. Oh, yes, of course, that's why, because the car speed is low. That's why it looks like that. So now we're going to have a much more realistic looking highway. Some of them are randomly moving left. This one right here. Okay, I think I realized what my mistake was. Thank you for sticking this far into the episode, but I think I figured out what I did wrong. This dot direction here, when we're creating a new lane, this random number generator generates between -1 and 1. But the problem is that 0 is included in that number. And so whenever 0 is spawned, it's multiplying the direction by 0, and the cars are not even moving at all. Like this car right here is not moving at all. Or if it is moving, it's moving very, very slowly. So actually what we need to do is we need to have a number that generates -1 or 1 randomly. So let's just really quickly write that. So it's inside this constructor. I added a checker that says if direction is -2, which is the default value, which is not going to be ever used. If it is, we're going to generate a random direction. And that's just so that here in the lane function, instead of adding in a random number generator, we can just call it with nothing, just so we don't have to add a random number generator every time we want a random lane. If we want a specific direction, we can just put in the specific number. But for now, it's fine. And that's what this looks like. The reason the game board is blank is because the cars are spawning up off the screen, and they're moving so fast that they leave before they even show up on here. So for now, we're just going to leave it like this. So next episode, once we add the car generation, you'll be seeing cars the entire time, because they're going to keep getting spawned on here on this right side if they're moving left, or on the left side if they're moving right. But now I'm just checking real quick that there are lanes moving right and left, and it's not just left. Okay, that was a small mistake also, that I had this direction being -2 right here. But then now we have a pretty good amount of cars. So we have, I don't know why they're being generated in such a weird fashion, but they would continue being generated in this exact same way. So I think we should leave it at this. We'll fix this in the next episode. We'll make it look a lot more, I guess you could say, natural spawning. And we'll also get the cars to be respawned at the top, at the left and right of the screen once they leave the screen. So I think this proportion of cars looks very, very nice. So I think if we could somehow get this to happen, it would be very good. Let's take a quick look at what the road looks like. So we have 10 lanes in a lane array. Inside each of the lanes, they each have their own Y value, and they each have their own direction. So there's some 1, some -1, some 1, some 1, -1s. They also have an array of cars that should approximately match the actual cars. So array 4, 4, 5, 5, 6, 6, 7, 5. Okay, that's fine. 5, 3, 5, 4, 6, 6, 8, 6, 6, 4, 5, 4. So it's fine. Okay, so everything works like that. Let's take a look at one of the random lanes. Inside the lanes, they have a gap that they're adding total. They have an array of cars that each have their own X value that they're storing. And then everything else is perfect. So thank you all for sticking this far. I know this was a long episode. I'll see you guys in the next one when we're adding, hopefully, the frog and the car's left-right controls.